Last lecture we're discussing the control of the relay. Is relay interfacing with the 8051. Then we are discussing this is the relay. There is one program related to the relay. On and off program is there, or two on and off of the transistor is there. The next we are discussing the stepper motor is there. In that stepper motor, in that stepper motor, we are discussing how this rotor will be rotated by giving the input to this stator of this motor is there. This is the full step sequence and half step sequence we are discussing there. There is a clockwise means for 9 8 C, it is half sequence there, anti-clockwise means 1 3 2 1 is there. Here we are discussing the one program for the full sequence of the stepper motor is there. And this is the connection of the interfacing of stepper motor is there. Here we have connected the port 1.0 to 1.3 means 4 pins are connected to the our stepper motor is there by using this ULN 203 supply motor or supply which is give the current to the supply current to the motor is there. So this is the driver circuit ULN 2003 is there. Driver circuit to drive the stepper motor is there. So we are discussing this circuit also in last lecture. Then there is a program just we are discussing. I want to explain this program again. Then we'll go to the next point is there. See, there is a two-stepper motor is interfaced with 8051 through driver card. Driver card means what? This is ULN 2033 the driver card. The motor is controlled through port 1. So 8 pins are connected to the port 1 is there. 4 pins for the one motor and second pins for the second pin, 4 pins for the another motor is there. Then step angle is the 1.8 degree. The step angle is 1.8 degree means if there is a stator, there is stator, your motor rotor will move with angle is the 1.8 degrees there. So this angle is 1.8 to move the rotor to the clockwise or anti-clockwise there. So it is the angle which is given by the motor is 1.8 is there. Okay. Then write a program to run the motor in anti-clockwise direction through an angle of 180 degree. So you have to rotate the motor into the anti-clockwise direction with the 180 degrees there. Okay. So for that purpose, what is the sequence of anti-clockwise there? So anti-clockwise sequence is, the anti-clockwise sequence is, suppose first giving the C6, then C, then 9, and then 3. 6, C, 9, 3 is there. This is the anti-clockwise. This is the anti-clockwise direction is there. So 6, 3, 6, C, 9, 6 is there. So see what is program is doing. Here we are giving the step is 1.8. So you have to record 180 degree. X step is equal to 180. Here giving the angle is 180 degree. Here giving the angle 180 degree. So X step is equal to 180 degree. So we require the 100 steps are there to move the motor into the anti-clockwise direction is there. To move the motor into the anti-clockwise direction. So we require 100 steps is there. So for that 100, we have to create a delays there. So for that 100, we have to create the delays there. If this value will be changed, then this value will be changes there. This 100 is given by this is the step angle, or you can say the number of steps required to rotate the motor is there. Number of steps required to rotate the motor is there. For that purpose, you have to use this delays there. So that's why I'm giving the 100 here is there. If you, the value of this will be changed, then automatically the value of this will be changes there. Okay. So see this program, move A into 66. Why 66? We are giving the 066 there. 06 is there. If I'm giving 06 is there, only one motor will be on is there. But here we have connected the two motor. We have connected the two motor is there. So due to that two motor, we have to higher bit, or you can say the lower nibble is given to the connected to the one motor is there, and second lower higher nibble is connected to the another motor is there. Okay, so this is the connection is done. This the connection is given to the motor. So that for that purpose you have to give the 66 is there. That is 66 is there. So first four pin of your port 1 is connected to the one motor, and second 4 pins are connected to the another motor is there. Okay, so this is the connection is 66. That's why I'm giving this 6 is for 66 for the one motor, and the another 6 is for the another motor is there. Okay, so then you have transfer this value to the port 1 is there. You have transfer this value to the port 1 is there. Port 1 you have transfer 66 values there. Then again we have to get the rotate left L. Rotate left L means what? After 66, what is the value of in your after 66 means after 6 the value is C. After 6 for the anti-clockwise direction we record value of C there. So how you get the C value? You will get the C value like this. When you rotate left A, see, that's why I'm writing here. Here is the value of 6 6. This is the 6 and this is the 6 is there. So this is the value of 6 6 is there. When you rotate left means this one will come to here, this one come to here, this 0 is coming here, this 0 is coming here, this one is coming here, this one is here, and this 0 is here. And again, this 0 will be go to the here is there. So this 0 will be go to the here is there. So see, this one comes to here. So this is the 1. Then another one is that this is the 0. This is the 0 is coming next. This is the 1 coming. This is the 1 coming. This is 0. And this 0 is going to the left side is there. This 0 is going to the left side there. So here is what 0 is there. Here is our 0 is there. So after that you can say 8 plus 4 is 12. 12 means this is the C and this is the C is there. This is the C and this C is there. So we have to rotate left means you have to rotate your motor in anti-clockwise direction. You have to rotate your motors in anti-clockwise directions is there. Rotate your motors in anti-clockwise direction is there. Okay. So in this way you have to rotate the motor. Then again what happened, this is the rotate CC is there. This is again called delays for the 100 steps there. The H jump L1 is there. H jump L1 is means what, you have to again move to the value of A to the P1. This is rotate L is there. So when you rotate left is there, so when rotate the left means what, this is the left is there. So you have to rotate the left is there, again you have to go the value is there, another value is there. So you will get another value is there, and this value is what is the, after this C, after that you get the value of 9, then you will get the value of 3 is there. So here after that C you will get a value of 9 is there on rotate left, and again and after that you will get value of 3 is there. After that you will get a value of 3 is there, again it will go to the another step, it will get to the 6 6 is there, 6 6 to C to the C is go to the 9 is there, and 9 is goes to the 3 is there. So this sequence will be repeated till you are not stop the program is there. So this is the program to rotate the motor in stepper motor in anti-clockwise direction. So last lecture we discussed this program, but just I want to revise this program is today's session is another is DC motor interfacing. Today's session is DC motor interfacing is there. Okay. The main purpose of DC motor interfacing is 8051. Main purpose of DC motor interfacing is the 8051 is what is the main purpose? To controlling the speed of your DC motor. By using this, you have to control the speed of the DC motor is there. So DC motor is connected to the 8051 is there. So that to control the DC motor, you have to control the DC motor. You have to means you have to control the speed of the DC motor. You have to connect the 8051 to the DC motor is there. You have to connect the 8051 to the DC motor is there. Okay. So what is the DC motor? You already know that. So here is the 8051. We have to use the motor driver, and this motor driver is connected to the DC motor is there. So 8051, this motor driver, and it is connected to the DC motor is there. Okay. DC motor, for example, DC motor whose speed is or direction of rotation can be controlled by using a program techniques, can be achieved by interfacing 8051 with the microcontrollers. To overcome the problem of their interfacing, a motor driver IC is connected between microcontroller and DC motor. The motor driver is detailed current amplifier. It takes a low current signal and gives the output high current signal, which can drive a motor. It is also a control the direction of motor. We can use any dual HBC. Okay. So main purpose of connection of 8051 with the DC motor is to control the speed of the DC motor. To control the speed of the DC motor is there. So By using programming techniques to overcome the problem, programming techniques you have to control the speed of the DC motor is there. To overcome the problem of the current capacity is there, we have connected the one motor or circuit which increase the current. When low current is input, then increase the high current. That's why your motor will be rotated is there. Okay, it is also rotated the, it is also control the direction of the motor. Means what is direction of motor? Means you can rotate the motor in clockwise direction, or you can rotate a motor in anti-clockwise direction. So direction of motor will be dependent on the, can be controlled by using this interfacing of 8051 with the DC motor is there. So this is the function of DC motor. Then just we are discussing here last point. Here we can use the edge bridge is there. We have to connect the edge bridge. We have to connect the edge bridge, and by using that edge bridge, you have to control the motor is there. By using edge bridge, you have to control the motor is there. So see how this will be done. What is meant by the edge bridge is there. So this is the edge bridge is there. Edge bridge is a derived shape of switching circuit which controls the motion of motor. It also full bridge based there are four switches. Make I, what is the meaning of this? Just I'm not reading this. See, this is the motor is there. You have to connect the motor. These are the edge bridge means four switches are there. This is one, two. This one, two, then three, four, three, four. This is the motor switches are there. One, two, three, four. This is the motor switches are there. By using that switches, we have to rotate the motor is there. By using that, we have to rotate the motor is there. Okay. So how this will be done? See, okay, which is called the higher side left, higher side right, lower side left, and lower side right. Higher side left, then higher side right, lower side left, lower side right is there. Okay, so these are the switches. By using that, you have to rotate the motor, give the direction of motor in clockwise or anti-clockwise direction. You can give the direction of the motor with clockwise and anti-clockwise direction is there. Okay, so see how it will be done. Just giving the next lecture, next slide is, see how when the high side left and a low side right, if there is high side left and low side right are close switches. If you switch close of high side left and low side right is there, then you can current will move from this side. Current will move to this motor is from this side. So motor will be rotate in forward direction. You can say it is in the clockwise direction. It is in the clockwise direction is there. So current will flow both side left, so low side right, and switch it on is there. So I'm discussing this, and then your motor will be rotated in clockwise direction. Your motor will be rotated into the clockwise direction is there. When this switch, where higher right side switch and lower left side switch will be switch closed, then your motor will be rotated from this side. Your motor will be rotated from this side. So this is a anti-clockwise direction. This is the anti-clockwise direction. So depending upon that, you have to rotate the motor by using this edge bridge construction is there. So in right side or left, sorry, clockwise or anti-clockwise, depending upon the close of the switches is there. So this is called the edge bridge is there. So you have to switch the switch and close the switch, and you can rotate the motor in clockwise or anti-clockwise direction is there. Okay. See how it is done is there. Suppose higher left and lower right, higher left and lower right is connected, then you have to go motor in the clockwise. Okay, just I was discussing there. Higher left and lower right, higher left and lower right, your motor will be in clockwise direction. Anti-clockwise means higher side right and lower side left. See, higher side right and lower side left. See, this is on, it is a clockwise. It is on clockwise. If it is high right and this is a motor, then see the anti-clockwise. Then again is higher left and higher right. Higher left and higher right. If these two switches are closed, there is no movement in the motor is there, because there is no path to move the current is there. There is no path to move the current to this motor is there, to the ground is there. So when these two are on, means higher side left and higher side right will be on, the motor is switch off, means stops. You can say declarates, or you can not movement of the motor is there. So it is on and on is there. If both are on, means lower left and lower right are on, then what happen, motor is stops again. Suppose these two are on, which one, this one and this one is on, again same problem is created. There is no conduction of the current through the motor from VCC to the ground is there. There is no conduction of the current from VCC to the ground is there. So due to that, your motor will be stop running, means there is a no conduction of the, or no rotation of the, not conduction, not rotation of the motor through this. If it is connected to the higher side left and higher side, sorry, lower side left and lower side left is on, then there is no conduction of the motor is there. Okay, so see, they are given here in, here they are given on, motor is runs clockwise. If it is on, then motor is anti-clockwise. And if it is two on are there, motor stop declaration. If last two on are there, motor stop the rotation is there. बघा तिथं काय just I would discuss here. If this is one and this is one, if the both are one, the motor will be rotated in clockwise direction. Motor will be rotated in the clockwise direction is there. Okay, these are open. This also open is there. So this is a clock. Next is the, if it is on, if it is on, both are on, then conduction motor will from this side. So your motor will be rotated in anti-clockwise direction. Your motor will be rotated in anti-clockwise direction is there. Okay. And suppose if you, this is on and this is on, with high side left and high side right, if both are on, high side left and high side right, if both are on is there, then what happen, your motor will not runs are there, the motor will be not run is there. Okay, again if this one is one and this one is one, and if it is not there, if both lower side left and lower side right are on, lower side left and lower side right are on, then your movement of the motor will be zero is there, means your movement of motor is zero, means your motor is not rotated is there. It is an open circuit of, due to this edge bridge is there, so your motor will be not rotated is there. Okay, this is the binary form is there. Means suppose if you one, this is also one, this is also one, and this is also one and one. So by using that these combinations, you have to rotate the motor in clockwise or anti-clockwise direction is there. You have to rotate the motor in the clockwise, anti-clockwise direction is there. Okay. See the program which we have to give one is there. If switch is connected to the 2.7, write ALP to monitor the status of switch. If switch is 0, DC motor moves in clockwise direction. If switch is 1, SW is 1, motor is moves into the anti-clockwise direction is there. Okay. Here they are giving, if S is equal to 0 clockwise, switch 1 and 4 is set, switch 2 and 3 is clear. And if switch is equal to anti-clockwise, switch 1 and 4 is clear and switch 2 and 3 are set. Just I'm taking this here and we'll understand program. See, by using this edge bridge, we have to write this program is there. Okay. So just there is one switch is there. I'm not drawing the switch is there. There is one switch is there. By using that switch, you have to on and off the motor is there. Okay, suppose what is the program is that there is one switch. There is one switch of pin number 2.7 means port 27 pin is there. Then if switch is zero, this will be rotated in clockwise direction, and if switch one, it is moves into anti-clockwise direction. This we are discussing the clockwise and anti-clockwise direction. Suppose a clear P 1.0, 1.2, 1.3, and 1.4. Motor is connected to the port 1 with 4 pins are there. We have to connect the motor to the port number 1 is there. Connected the motor to the port number 1 is there. So this is the P 1.0, 1.1, 1.2, 1.3 is there. So this is the 4 pins are there which is connected to the motor there. Then next, set bit 2.7. Set bit 2.7 means what? You have to set means you have to on the switch is there. So you have to on the switch is there means what? You have to rotate the motor within. If it is one, it is motor, it is in the anti-clockwise direction. If it is one, it is motor in the anti-clockwise. If set bit, where the set bit is 2.7, then it will go to the next line there. We'll discuss this next time. Up, jump if not bit, p is equal to 2.7, comma clock. 2.7, comma CLK to इथं. म्हणजे जर सपोज आपलं जे काय कुठलं बीट कशामधलं तर पोर्ट मधलं बीट कुठलं 2.7 हे 2.7चं बीट जर सेट नसेल म्हणजेच काय इफ यू हॅव टू पुट अ व्हॅल्यू ऑफ पी 2.7 इज इक्वल टू 0 इफ यू पुट अ व्हॅल्यू ऑफ पी 2.7 इज इक्वल टू 0 then you can say that motor is not means p 2.7 is there means it is 0, then motor will move into the which direction? It is into the clockwise direction. Sorry, clockwise direction is there. And if it is jump switch is equal to 1, it is equal to add. इथं आपण काय केलंय इथे we are discussing set bit is equal to 2.7. आपण set bit काय केलंय 2.7 केलंय म्हणजे it is move into the anti clockwise direction. It is move into the anti clockwise direction is there. आणि जोपर्यंत त्याच्यामध्ये 0 येत नाही, if it is contain a 0 value, then it will go to the clockwise. But here we have to move into the clockwise direction. So see what is the clear p, all ports are clear, then set bit 1.0. So here we have put a value of 1.0, here put it 1.0, then clear p 1.2, the 1.1, 1.2, and set bit, here is a bit set 1.3, it is 1 is there. So you can say this is the 1.1 pin of port, this is 1.2 pin, this is 1.0 pin, one point zero. The argument set bit, it is your anti-clockwise direction means what? You have to rotate this one. So here is 1.0, 1.1, switch 1 and 4 are the close. Switches are there. For clockwise direction, switch number 1 and switch number 4 is connected. For anti-clockwise direction is 1 and 4 clear, 2 and 3 are the set, which is port number 2 and port number 3 will be on is there. Okay. So see, when set bit 2.3 means switch is on, it is act as a clockwise direction. So it is a clockwise direction. Set bit is equal to set bit 1.0 is there, then clear 1.1 is there, then clear 1.2 is there, then set bit 1.3 is there. Set bit 1.3 is there. So you will get a edge jump up is there. Okay. When it is a jump if not bit means if it is contain a zero value, it is contain a zero value, it is rotated the zero value, it is rotated into the clockwise direction. So here is set 1.1 is there, 1.1 set bit 1.2 is there, and then clear 1.3 and edge jump to the up is there. So it will go to the edge jump to the up. So motor will be rotated into the continuous direction. Motor will be rotated into the continuous direction is there. Okay. So this is the program is there. Means when this bit and this bit is on, if this the connection is there. Okay. For clockwise, this bit and this bit is on. When this is on is there for clockwise direction, and for clock anti-clockwise direction, set bit 1.1. So you have to set bit this one, and set bit 1.2. You have to set this bit one is there. So here is a set bit 1.1 and set bit P 1.2 is there. So by using that, you have to connect this in clockwise and anti-clockwise direction. You have to connect in anti-clockwise and clockwise direction is there. Okay. When you rotate this, and it will go to the edge jump up is there. It will go to the edge jump up is there. So where is up? Here is the up is there. Here is the up is there. So in that up, you have to again you have to rotate the motor in clockwise and anti-clockwise direction depending upon the values present into the P 2.7 is there. जोपर्यंत P 2.7 मध्ये किती आहे ते समजत नाही, still your motor is rotated in clockwise and anti-clockwise direction is there. Your motor will rotate into the clockwise and anti-clockwise direction is there. Okay. So this is the last point in our unit number 6 is there. Digital thermometer using 805 means what? You have to connect the thermometer or a sensor to the 8051. Interfacing of the sensor to the 8051 is there. And by using that interfacing connection, you have to display the temperature of room, or maybe a temperature of room temperature. You have to what we have to display on your LCD displays there. Okay. So please see, this is the LM35 sensor we have to use. Here is LM35 sensor is used to measure the temperature. This is the one sensor. Sensor means you have to sense the things are there. So things which are surrounding things are there, temperature, then moisture. So these are the different sensors we have to require to connect these switches to the. So see this diagram properly and see what is the connection is done. So what is the use of this analog to digital converter is there, then what is the use of this connection? Please see this, just I will discuss then 2 to 3 minutes. Please see this and remember, see this which port is connected to the LCD, which port is connected to LM35, which port is connected to the ADC. Please see this, then we will discuss the points are there. Okay, please see this 2 to 3 minutes. Just zoom your mobile and see the connections are there. So this is the last point of your unit number 6 is there. Digital thermometer is there. You have to connect the thermometer to the 8051. I think we'll see this diagram. Just see what is the thermometer LM351 is there. LM35 thermometer. This is the connection of the LM325 thermometer is there. So it is contain a three pins are there. It is contain a three pins are there. So this is the ground pin. This is the output pin. It is a 1 milliwatt per degrees there Celsius there. Means if there is 1 degree Celsius will be changed, the voltage will be changed with the 10 millivolt is there. This is supply voltage given to this between 4 to 30 volt is there. So this is supply pin, this is a ground pin, and your output is connected to the here. So you have to give this output to your 8051 is there because our 8051 is work on that output is there. So see this, see the connections are there. Okay. So this is our LM3. This diagram is draw into the Proteus software is there. If you are all the electronic circuits are designed in your Proteus software also. So Proteus is one of the software is there. In that software, you have to take the ICs, different ICs are there, connections are made, and you can see the output on the same Proteus is there. So Proteus is the software is there. You have to make the connection is like this. The connection which is shown here in ADCM is the directory software. You have to just click on the stepper motor or click on the ADC that directly connect to the 8051. But here in your Proteus software, you have to by using a mouse, you have to connect the connections are there. So there are different ICs are there. We have to make the connections to the using your different ICs are present in Proteus softwares are there. So you have to make the connections and do this to see the outputs of each and every circuit is there. So this diagram is done or draw into the Proteus software is there. Okay. So this is the LM35 there, temperature sensors are there. This is the ground pin. This is the VCC is there. So only two number pins we have to see. Then pin number 2 is there. We are discussing pin number 1 is connected to the VCC. Pin number 3 is connected to the ground. Only two pins are connected to this input is there. This is the analog input. See, our temperature is not a digital form. You know that temperature will be why it is analog form. So you know that the temperature will decrease or decrease or increase depending upon the environment is there. So temperature decrease and increase there. So it is in the analog form. So we have to connect this connection to the connect this to the analog input is there. You have to connect this to the analog input is there. So here analog inputs we are discussing the AD 0800 there. Here container eight analog inputs are there. You know that eight analog inputs are there and three pins are there. We have to use to select the which analog input is there. There is a three pins are select which are use the which analog input is there. Okay. So this is the connections are made. So one input IN0, this is IN0. It is connected to the two pin of your which one temperature sensor is there. Then which pin you have to select IN0. So this is connection is given to this here. So these connections see 1, 2, and 3. This connection is given to the so these are the registers. These are three registers are there, which is connected to the I think P07, P06, and P05 is there. Okay, this is connected to the P05 to P07 is there. So P05, P06, P07 is there. So here we have to connect it to this register is here is a by using that three register or three inputs are there. You have to give the input to the 000. Give the input to the 000. Why 000? Because you are connected the port input analog input to the port pin number IN0 is there. So you have to analog input IN0 is there. So you have to connect this to the registers are there. So IN0 is given that. So due to that IN0, you have to select by using the register is there. Okay. The next point is in that here connection is done. Then This is a crystal oscillator connected to the crystals are there. Then another, when you gave the analog output, where the analog output is given, this is the analog input means this analog input is converted into the digital form. So digital output for the analog ADA0 is 8 digital outputs are. So this is the 8 inputs, 8 digital outputs are there. And these digital outputs are connected to the port number one is there. So port number one, 8 pins are connected to the ADC, my analog digital output is there. So input is given, means analog input or temperature sensor input is given to the ADC 0808 is there, pin number IN0 is there. These pins are selected by the three input pins, which is the port 0, 7, 6 and 5 is there. So by using these three pins, you have to select the IN0 is there. Then in your ADC0, the conversion is made, means you have to conversion of analog into the digital. Your conversion of analog into the digital form is there. So this digital form is given to the 8051. This digital form is given to the 8051 is there. So you have to convert this uh, analog to digital, and this digital form connected to the port number one of 8050. It is connected to the port number one of 8050. So this is coming to the output is the port one is there. Again, when you have to connect this output, to the LCDs, there means what, ADC output is coming to the 8051. So 8051 understand that the temperature is supposed 20 degrees Celsius of your room temperature is there. Then you have to display this temperature, and for that purpose you have to use the LCD display. So we have to use the LCD display there. You know that LCD is having the 8 input pins or 8 data pins are there. These 8 data pins are connected to the port number. This one is port number one, or port number 2 to 6 is there. Okay, so you have to connect, I think, three port number. Okay, this is connected to port number 3 is there, 3 to 7. You have to connect, these ports are there. Port number 3 is connected to the LCD there. Then LCD is having the three pins. You have discussing three pins: RS pin, E pin and RW pin. These are connected to the one port is there, port number 2 is there. Okay, and this is the VC and ground. When your temperature will be coming from this LM351, LM351 is there. This is LM351. This is connected to the IN0 is there. This is connected to the IN0 is there. Then we have, by these selections, the conversion is made. This conversion is from analog to digital is there. So this digital output is goes to the 8051 is there. So 8051, the digital output is connected to the LCD is there. You have to 8051, this digital output is connected to the LCD is there. So your LCD will be display the, suppose 20 degrees Celsius. Suppose 20 degrees Celsius is the output of this temperature is there. So you have to give the 20 degrees Celsius. So this is a connection of thermometer to the 8051. This is the connection of thermometer to the 8051 is there. Okay. So you have any difficulty regarding this? Hello. So these are the 4 points of unit number part 2 means unit number 6 is there, because unit number 5 and unit number 6 are the interfacing of 8051. Unit number 5 and unit number 6 are the interfacing of the 8051 with the relay ADC, DAC. Then you can say the temperature controller is there, then stepper motor is there, DC motor is there. You have to connection of this interfacing connection of the 8051 with these peripherals. You can say that these are the peripherals you have to connect the 8051 is there. So any difficulty regarding this unit? understood the program related to that. The relay program, one is the relay program, one is the stepper motor program, and one is the DC motor program. So these are the programs for connection of 8051 with 806 is there. Okay. So you want to repeat any point in this unit number 5 or 6? Are you getting the program? So if you understand, then tell me what is the, if I'm writing here RRL is there. So what is the output of this? If suppose there is container 66 is there, so what is the output of this pin? What is the output of this? After rotate right is there. This is a 66 is there. Here is a 66 there. 66 is there. Here is 6 is there. After the rotation of right, what is the output of this? This pin. You can say that in this column, what is the output you have to get after 66? Give an answer in chat box if don't, if you have answer is there. If I am giving the input of A66 is there, we don't see on full screen. If you are giving the 66 into the accumulator is there, or accumulator the port 1 is there, and if I am rotate right is there, today we are rotating left is there, if I am going rotate right is there, then what is the value of the A is there? If A is contains 66, and if I am giving the rotate right is there, so what is the output of this, or what is the value of present in the accumulator after this execution of this command is there? ते कमांडचं एक्झिक्युशन झाल्यानंतर आपल्या accumulator मध्ये किती व्हॅल्यू येईल? किती वाले? Give me the answer in chat box if you understand this. What is the value of the accumulator after this rotate right is there? See, if it's rotate right means what? Your rotate right means what? What is the meaning of rotate right? This is one is goes to here. This one will be go to here. this 0 will become here, this 0 will become here, this one becomes here, this one becomes here, this 0 will be here, and this 0 is coming to the here is there. So what is the answer? This is the 0, then this is the 0, it will come to the 1, here is come 1, it becomes 0. So it is 0, it is 0, it comes to 1, 1. Here is again a 0 is there. Here is again 0 is there. And then it becomes 1, 1. So you will get answer. This is the 3, this is 3. So after that, you will get the answer is 3, 3. You will get the answer is the 3, 3 is there. You will get the answer is 3, 3. So this is after the rotate right is there. So you will get answer of 3. When again you rotate right is there, your answer is what is rotate right, your answer is different is there. Okay, so answer is your different is there. So in clockwise direction you will get the output there. If it is 3 3, after that 3 3 right side is there, 3 3 you will get value of 9 is there. After 3 3 clockwise direction you will get value of 9 is there. After rotate right is there, you will get value of C. Again rotate right is there, you will get value of 6 is there. After that your rotate right is there, you will get the value of 3 is there. Again rotate right, you have to, this process will be continuous there. This process will be continue of the clockwise direction is there. Okay. So this is rotate right is there. In previous program, a simple program you have to give directly sequence to the input of the accumulator. You are giving the sequence to the input to the accumulator, but you have to remove this portion is there of 4 to 5 lines. You have to only give the one line is the rotate right or rotate left is there. You are giving only one line is the rotate left and rotate right are there. Rotate left and rotate right are there. One line you have to rotate the motor in right side or left side is there. Okay. So this is the program for the DC. Now this is for program for the stepper motor is there. So in offline examination, such a programs are asked. In offline examination, such a programs are asked to give the step instruction. If there is a online examination is there is also ask the question to create. There is also ask the question is there. They are giving the step values there, and you have to calculate the how many steps are required to rotate the motor is there. So you have to calculate by using x step is equal to 180 means degree they are giving, and steps they are giving for the one step is there. So degree divided by the one step is there, then you will get the answer. This is the answer of the D laser. So number of steps required to rotate the motor is the 100 is there. So if you have any difficulty of regarding this portion, ask me. If you have this difficulty, ask me. Then I will. so you don't have any difficulties there.